This is part 3 in the SMC Familiarization series. This segment focusing on compression molding of sheet molding compound. I'm Rob Holcomb, Engineer and Product Manager for IDI. Previous parts gave an overview of sheet molding compound and a brief look at how SMC is compounded. The previous segment ended with the SMC having arrived at the molder's facility, and I'll take this opportunity to reiterate the importance of stable storage conditions and the positive effect that can have on repeatable molding performance. This segment will focus on the processes involved in compression molding, the primary manufacturing method using SMC. Allow me to explain the concept of compression molding before getting into the practical production elements. Compression molding is the process used to turn SMC into a molded part. A mold, composed of two steel halves, is set in a hydraulic vertical press. The tool is kept at about 150 Celsius, with a slight differential from core to cavity to prevent binding. The press is sized to be able to apply about 7 megapascals of in-mold pressure. The pressure is applied for a short period of time, a few minutes typically. Then the mold is opened and the part removed. Different geometries and chemistries may dictate changes to the baseline temperature, differential, pressure, and timing mentioned here. The heat of the tool temporarily lowers the viscosity of the sheet molding compound. This allows it to flow and fill the cavity under pressure. The heat and pressure also kick off the final curing reaction. The combination of time, temperature, and pressure are the factors that convert uncured SMC into a cured composite part. With the basics of compression molding behind us, we can now step back and address the charge. The charge is the lump of SMC that is placed into the tool for molding. The number of layers, shape of layers, and location of layers of SMC comprise the charge pattern or charge stack-up. The charge is prepared outside the tool on a prep surface. An operator or machine feeds some amount of SMC out of the storage box. The SMC is then slit and the barrier film is peeled away to produce a ply. A work instruction or program typically dictates the number of plies, their size, location, and the final expected weight of the total charge. Once the tool and the charge are ready, the charge, all of its pieces and plies, is placed precisely in location in the tool. The charge pattern and placement are an early optimizing exercise during validation. They are set and repeated in production to produce consistent results. With the charge prepared, it's time to load it into the mold. It's important to start with a clean mold, with no remaining resin from the last shot on the mold surface or shear edge. This ensures no inclusions and a satisfactory filling out of the tool. The tool surface may be prepared with an applied mold release, though some formulations include a mold release, making any additional simply overkill. All the pieces of the charge are laid into the tool according to the charge pattern work instruction. The work is done quickly, and the press cycle begun immediately after to prevent the SMC from beginning to pre-gel as it sits on the hot tool. The press cycle begins with a fast close to get the tool halves close together with minimal wasted time. The slow close begins just before the SMC is brought in contact with the upper half. If the tool has vacuum, The vacuum seal is made and engaged at about this time as well. The slow close continues as the SMC is compressed and heated between the two halves. As pressure builds, the SMC flows to fill the tool. The slow close phase ends once the press has reached a preset level of pressure. The press now dwells at this pressure setting, the SMC having fully filled the part shape, giving the SMC time to cure in place. Advanced processes may vary the pressure during the dwell period. While the mold is shut and the part is curing, the next charge is being prepared on the sideline. Once the part is cured, the press opens and ejector features like pins or poppets aid in lifting the part free of the mold surface. The part is removed by hand or a machine, the tool is cleaned and prepped, and the cycle starts again with the next charge. Even after the part is ejected and removed from the mold, the cure reaction continues for a brief time. For parts with tight dimensional tolerances, it is highly beneficial to secure the part in a cooling fixture. Cooling fixtures hold the part at its datums and critical profile points to help it set up in its intended shape. These combat the tendency of warping caused by the continued reaction and differential cooling of the part's features. A secondary process called post-bake is often employed, where the part is loaded into the cooling fixture, but then sent through a bake cycle. The bake cycle holds the part at an elevated temperature for an extended period. This process can help cure off any remaining VOCs, mitigating unfavorable smells and coating adhesion concerns from outgassing. Post-baking in a fixture can also support a tighter final part tolerance as the part is fully cured in its held shape. It is also possible to shift some of the required cure time out of the press and into the post-bake, reducing the takt time of the press and helping with line balancing calculations. This concludes this segment, Familiarization with Compression Molding SMC. Next, we conclude the look at SMC manufacturing with post-processing of composite parts.